Hi everyone, this is Dr. Nak, and today we are going to evaluate and graph exponential functions. Let's first go with what is an exponential function. Well, an exponential function is a function of the form f of x equals a to the x, where a is greater than 0 and a does not equal to 1. So be careful here. So for example, if we have f of x equals to 3 to the x, this will be exponential function. But in this case, our base is a numerical value. So our base is a number, which is 3. Now, do not get confused with this guy right here. So f of x equals to x to the third. So this is more of something that we're very familiar with. But note that x to the third, our base is the variable. So in this case, our base is x. The first portion of this section is to learn how to graph the exponential function. So let's get started. Example 1, graph f of x equals 3 to the x and g of x equals to 5 to the x. So what I'm going to do is make the chart, and so that way we can plot those points. So let me just first go with our f of x equals to 3 to the x. Now, it does not matter what value of x that you're going to pick, but make sure that you're going to have enough points. I usually plot at least 5. So let me just start off with this. Let's go with -2, -1, 0, 1, 2, what the heck, let's just throw another one, 3. All right, so now what we're going to do is we're going to compute the corresponding y value. So let's first go with when x equals to -2, our f of x is going to become 3 to the -2. Now remember, 3 to the -2 is same thing as 1/3 squared. So this is going to give us 1/9. So since we need to plot these points, let me just extend the chart a little bit. So let's just go with x comma y. So when our x value is -2, corresponding y value is going to be 1/9. Now let's deal with when x equals to -1, then our f of x is going to become 3 to the -1, which is 1/3. So as an ordered pair, I need to write this as -1 comma 1/3. And let's go with when x is 0, so we're going to have 3 to the 0. Do you remember what that is? Yup, 3 to the 0 is 1. So in this case, we're going to have 0 comma 1. And when x equals to 1, oh, that one's really cute. It's just 3 to the first. Ta-da! It's just 3. So we're going to be plotting 1 comma 3. All right, x equals to 2, we're going to have 3 squared. So you're going to have 3 times 3, 9. So 2 comma 9. And then when x is 3, we're going to have 3 to the third. Be careful, 3 to the third does not equal to 9. That's like a common mistake there. But 3 to the third is 27. So here you're going to have 3 comma 27. All right, so let me first draw this graph out. All right, so I'm going to be starting with the first ordered pair, which is -2 comma 1/9. Yikes. Okay, so let me just go with when x is -2. Our y value is 1/9. So if this is 1, it's the 1/9 of that grid. So you will be maybe like almost touching the x-axis, but it's not touching it. All right, now the next point that we need to plot is -1 comma 1/3. So here we're gonna have -1 comma 1/3 will be, you need to divide that interval into 3 equal pieces and then take the 1/3 of it. So like maybe it's like right here. All right, now let's go with 0 comma 1. All right, that one's easy. 0 comma 1 is right here. All right, now who's next? 1 comma 3. Let me just make this grid already. All right, so 1 comma 3 is going to be right here. All right, and then 2 comma 9. Oh my goodness. 5, 6, oh no. Oh no, 9's way up there. Oh well. All right, I'm just gonna go with it. So here, 2 comma 9 will be maybe, oh goodness, maybe over here. All right. And then 3 comma 27, I'm not gonna even plot that because it's gonna be at the very, very top of this page, I should say. All right, so now if I graph this out, I'm just gonna connect those dots nicely. And notice that this function is an increasing function and it's gonna increase all the way up to positive infinity. But what about that left-hand side of the tail end of the graph? Is it gonna touch the x-axis? Is it gonna cross the x-axis? What is going on? Well, let's just check. All right, we started out with x equals to negative 2, right? So if I choose x equals to negative 3, then you're gonna have 3 to the negative 3, which is 1 over 3 to the third, which is 1 over 27. So still that number is going to be positive. All right, so let me see, when x is negative 3, well, it's gonna be really, really hard to plot. Okay, it's getting closer and closer to the x-axis, but guess what? It's never ever going to touch that x-axis, believe it or not. So if you want to check it out, you can plug it in when x equals to maybe negative 10. All right, then you're gonna have what? 3 to the negative 10, so you're gonna have 1 over 3 to the 10th. So that's gonna be super duper 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 tiny number. But still, the y value is going to be positive. So that's the whole point of it. So make sure that this graph on the left tail end does not cross the x-axis. I think that's good enough. So this graph is going to be our f of x equals to 3 to the x. Now let's go with our g of x, which is 5 to the x. So let's just pick the same x values. All right, so when x is negative 2, we're going to have 5 to the negative 2, which is 1 over 5 squared, which is 1 over 25. So the point that we need to be plotting is negative 2 comma 1 over 25. All right, now when x is negative 1, we're going to have 5 to the negative 1, so it's going to be 1/5. So we need to plot negative 1 comma 1 over 5. Now when x is 0, 5 to the 0 is 1. So here you're going to have 0 comma 1. When x is 1, that's just going to be 5. So you get 1 comma 5. And when x equals to 2, 5 squared is 25. So you're going to have a 2 comma 25. And then when x is 3, we have 5 to the third, which is 5 times 5 times 5. So which is, what is that? 125? Goodness. So here you're going to have 3 comma 125. So what I want you to notice is this. When x gets bigger, do you see that the gap of the y values gets much, much bigger? So keep that in mind, because exponential function grows really, really fast. So let me just plot those points. All right, so when x is negative 2, we got 1 over 25. So that's super duper close to the x-axis, but it's not touching the x-axis. All right, now next one is negative 1 comma 1 over 5. So negative 1 comma 1 over 5, it should be lower than 1/3. So I'm just gonna, I don't know if you can see this or not. So I'm just gonna dot it a little bit below the blue dot, which is from 3 to the x. All right, now next one is 0 comma 1. Notice that our 3 to the x also gonna pass through 0 comma 1. Now let's go with when x is 1, we have 1 comma 5. 1 comma 5. So that will be right here. All right, now next one is going to be 2 comma 25. So notice that when x is 2, 25 is way on the top of the paper. So here I'm just going to write it like, draw this like this. I should have made this grid much bigger. Sorry, you guys. So here, this is what's going to happen. It's going to keep increasing, shooting up towards positive infinity. And the left tail end of the graph, it's not going to touch the x-axis, but it's going to get really, really close to it. So let me label this graph as, let me just bring it over here, g of x equals to 5 to the x. Now the way I drew the graph, it's a little bit difficult to see what's going on. So let me just blow it up, okay? So first of all, 3 to the x, let's just say it's going to go, let me see. Let me just make the grid like this. So pretend this is 0, 1. So for sure, 3 to the x is going to go through there. Okay, and then, so let me just exaggerate a little bit. So let's just pretend that it's going to go like this. So that's f of x equals to 3 to the x. Now for the g of x equals to 5 to the x, so this is what's going on. It's also going to go through 0, 1, but it's going to get closer to the x-axis much quicker. I'm talking about the left tail end of the graph. And when it passes 0, 1, it's going to be sitting inside of 3 to the x. So I don't know if you can tell by looking at this graph, but this is our g of x equals to 5 to the x. For this particular f of x and g of x, note that the base is 3 and then 5, which are greater than 1. Now, what I want you to focus is the value of x, maybe x starting from -1, 0, and 1. Let me just circle those values. So when x is -1, we're going to have -1, 1/3. When x is 0, it's going to be 0, 1. Now, when x is 1, you're going to have 1, 3. All right, now let me do the same thing for 5 to the x. I'm just going to look at the value x equals to -1, 0, 1. So when x is -1, you get -1, 1 over 5. When x is 0, 0, 1. When x is 1, 1, 5. Do you notice some kind of a pattern here? Well, first of all, when x is 0, do you notice that our y value is always going to be 1? Because if we have base 6, 6 to the 0th power is 1. If you have a base 10, 10 to the 0th power is always going to be 1. So no matter what, when x equals to 0, the corresponding y value is always going to be 1 for the exponential functions. Now let's take a look at when x is -1. Well, the y value is going to be 1 over 3. Now, look at the base of f of x. We have the base of f of x to be 3, isn't it? So if we write f of x equals to a to the x, do you see that when x is -1, you're always going to have -1, 1 over a. Now, is that also true for our function g of x? I think so. So let's take a look at g of x, which is 5 to the x. When x is -1, our y value is 1 over 5, where 5 is the base. So again, when x is -1, our y value is always going to be 1 over 5, which is 1 over a, which is going to be the base. So this is what I'm looking at. G of x equals to a to the x. All right, now let's take a look at when x equals to 1. Let's go back to our f of x equals to 3 to the x. So when x is 1, y is 3. Now let's look at g of x. When x is 1, y is 5. So isn't it nothing but when x is 1, corresponding y value is always going to be the base value. So which is going to be 3 for 3 to the x, but in general, this will be 1, a. All right, now let's take a look at g of x. When x is 1, we have 1, 5, where 5 is the base. So here you're going to have 1, a. So keep that in mind. let's just summarize what we just talked about. When x is -1, 0, and a 1. So what was the pattern? When x is -1, corresponding y value was 1 over a, where a is the base of the function. And when x equals to 0, it was always going to be 1. And when x is 1, corresponding y value is going to be the value of the base, which is just the a. So the property of exponential function goes like this. Well, for sure, it's going to go through 0, 1 no matter what. And when x is -1, our corresponding y value is going to be 1 over a, where a is the base. So let me just randomly pick the value of 1 over a to be here. And let me just plot that point. When x is -1, it's always going to be 1 over the base, the value of the base. All right, now let's take a look at when x is 1, our y value is going to be just a. So if the base is 3, for sure you're going to have to plot 1, 3. But since we're doing this in a general way, so let me just denote our a to be like maybe right here. And then I'm going to plot 1, a. All right, and then as long as you know how the exponential function is going to look like, all you have to do is know those 3 key points and then connect those dots and draw the exponential curve. So which is going to look something like this. Remember, it's never going to touch the x-axis. So let's just call this guy f of x equals to a to the x, but the base a is greater than 1. Now let's summarize the property of the graph of f of x equals a to the x when a is strictly greater than 1. Let's start out with the domain. So what's the domain of this function? Remember that the domain is settable x values where the function is defined. Well, this function is defined from -infinity to infinity, which is same thing as all real numbers. So the domain for the exponential function is going to be -infinity to infinity. Now let's go with the range. Range is settable y values where the function is defined. To find the range given a graph, you need to look at the graph from bottom upward. So you need to determine where does my graph start along the y-axis. So let me see. Remember the left tail end of the graph? It's going to get very, 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 very close to the x-axis, which means that y is 0. But since the tail end of the graph is never going to touch the x-axis, you're never going to reach the value y equals to 0. So the range is going to be open parentheses 0, which indicates that 0 is not in the range. So, and then where does it go? Well, y value, look at the right tail end of the graph. The y value is going to keep going up and up and up and then towards the positive infinity. So the range is going to be open 0, infinity. Next, let's go with the x-intercept. Now remember, x-intercept is the point where the graph is going to cross or touches the x-axis. But remember that the left tail end of the graph is never going to touch that x-axis. So, do we have any x-intercept? Nope, I don't think so. So, there are no x-intercept for the exponential function. So, I'm just going to write it as none. Next, let's go with the y-intercept. Y-intercept is where the graph is going to cross the y-axis. Well, there's only one point the graph is going to cross the y-axis. That's at 0, 1. So therefore, y-intercept is going to be 0, 1. Now let's go with the additional key points besides 0, 1. As we talked about earlier, no matter what, when x is -1, our y value is going to be 1 over a, where a is the base. Now, another one is when x is 1, we're going to have the corresponding y value to be just a. Next, let's go with the asymptote. Well, asymptote is nothing but our x-axis, isn't it? So, how do you write that as an equation of a line? Y equals to 0. So I'm just going to write it as asymptote is at y equals to 0, which is same thing as the x-axis. So these are the properties of the graph of the exponential function when the base is greater than 1. Now let's talk about what's going to happen if the base is less than 1. As an example 2, let's graph f of x equals 1/3 x, 1/3 to the x, and g of x equals 1/5 to the x. We're going to do the same thing as what we did in example 1. I'm going to pick some random x values, then write down the corresponding y values. But let's just keep it the same as example 1. So the x values that I'm going to pick are -2, -1, 0, 1, 2, and a 3. All right, so let me just get this one over with. -2, -1, 0, 1, 2, and a 3. All right, so let's first go with f of x. So when x is -2, then we're going to have 1/3 to the -2, which is same thing as, well, if you have a negative exponent, you're going to have to flip the base and then attach the positive exponent on that base. So here you're going to have 3 squared, which is going to give us 9. So we need to plot -2, 9. All right, now let's go with when x is -1, we're going to have 1/3 to the -1. So this is going to be just 3 to the first, which is 3. So you got -1, 3. When x is 0, we're going to have 1/3 to the 0. Anything to the 0th power is 1, provided that the base is not equal to 0. So here you're going to have 0, 1 again. Now let's go with when x is 1. Then we're going to have just 1/3. X is 2, we're going to have 1/3 squared, which is 1/3 times the 1/3, so which is 1/9. And when x is 3, then we're going to have 1/3 to the 3rd power, which will give us 1/27. So let me just write in terms of an ordered pair. So you got 1, 1/3, and then 2, 1/9, and then 3, 1/27. Now let's do the same thing with the g of x. G of x is 1/5 to the x power. So here when x is -2, we're going to have 1/5 to the -2. So this is just 5 squared, which is 25. So here you're going to have to plot -2, 25. Now when x is -1, then we're going to have, let me see, 1/5 to the -1, which is just 5 to the first, 5. So here you're going to have -1, 5. All right, now when x is 0, then you're going to have 1/5 to the 0th power, so we're going to have 1. Again, exponential function, notice that it's going to go through 0, 1. And then when x is 1, you're just going to have 1/5. And then when x is 2, you're going to have 1/5 squared, which will be 1/25. So you got, oh, I forgot the 1 here. So we got 1, 1/5. And then we got 2, 1/25. And then when x is 3, goodness, our y value is going to get really, really tiny. You get 1/5 to the 3rd power, which will give us 1/125. So 3, 1/125. Now let's graph these two functions. So I'm going to start off with our f of x. So let me plot -2, 9. Oh no, it's out of the grid. So I'm just going to put like maybe up here. All right, and then -1, 3. -1, 3, that I can plot on this graphing paper. And then 0, 1. And then 1, 1/3. So when x is 1, our y value is going to be 1/3. So maybe over here. And then 2, 1/9. So when x is 2, our y value is going to get closer and closer to the x-axis now. So 1/9, maybe like here. And then when x is 3, it's gonna get even smaller, which means that this tail end of the graph is gonna go towards the y equals to 0, which is the x-axis. All right, so it looks like our graph is going to look something like very similar to the example 1 graph, but do you notice the difference? Let me just keep going like this. Do you notice the difference? When the base was greater than 1, do you see that the graph went the other way? The other way meaning the graph was increasing. Here, when the base is less than 1, our graph is decreasing. Anyways, let me just label this as our f of x equals 1/3 to the x power. Now let's go with a g of x. So first I need to plot -2, 25. Goodness, that's like way on the top, so I'm not going to even plot that. Now the next ordered pair is -1, 5. So I think that I can do. -1, 5. Oh, barely. All right, so here we go. And then 0, 1. Next one is 1, 1/5. Oh goodness, now it's gonna get really tiny. So 1, 1/5 will be a little bit below the blue dot from our f of x. And then when x is 2, the y value is even smaller. So it's gonna get closer to the x-axis a little bit faster than f of x. So let me just squeeze it in there. Excuse me, I'm gonna squeeze in there. All right, and then when x is 3, our y value is 1/125. So it's basically almost touching the x-axis. But anyway, so if I graph this out, again, it's really hard to draw this on this tablet that I'm using. So please pretend that the tail end of the graph is never going to touch that x-axis. So the one that we just drew the graph of is our g of x equals 1/5 to the x power. Now notice that our g of x decreases a little bit quicker than our f of x when base is less than 1. Anyways, let's do the same thing as what we did earlier in example 1. Let's get the key points. So the key points were when x equals to -1, 0, and a 1. So I'm going to circle that. All right, now let's notice the pattern. Well, when x is 0, looks like it's always going to be 0, 1. All right, now when x is -1, you're going to have -1, 3. But 3 is the reciprocal of our base, isn't it? So if I denote our function as f of x equals a to the x, then when x is -1, then our corresponding y value is going to be 1/a. All right, now let's go with when x equals to 1, it's going to be 1/3. So isn't that our base itself, which is a? So you're going to have 1, a. Now, same thing's going to happen for our g of x. So, of course, we got 0, 1 going on all the time. Now, let's look at when x is -1. All right, so let me just write down on above g of x to be maybe a to the x again. So here, our a is 1/5. So, our y value when x is -1 is 5. So that will be the reciprocal of our a. So which will be 1/a again. And then when x is 1, you're just going to have the base itself, which is a. Okay, we're going to do the same thing as what we did in example A, but the only difference is that a is less than 1. Now, let me just jot down the key points that we just talked about. So here are the 3 key points when x is -1, 0, and a 1. So let me just first jot the easiest one. That will be 0, 1. It's right here. So it's always going to go through 0, 1. Now let's talk about when x is -1. Now remember, our base a is less than 1. So our a is like maybe 1/3 or something like that. So notice that if a is 1/3, let's just say, then do you see that 1 over a is going to be 1 over 1/3, which is going to give us 3. So in fact, our 1 over a is going to be bigger than y equals to 1. So keep that in mind. So here, what I'm going to do is I'm going to just randomly pick 1 over a value. So let's just go right here. So maybe right here, I could call this guy 1 over a. So pretend that's 1 over 1/3, which is going to give us 3 or something like that. So of course, that means that the y value is going to be greater than 1. But anyway, so when x is -1, it's going to be at 1 over a. So let me just jot it down here. All right, now let's talk about when x is 1. Well, when x is 1, a is just the base itself, but a is less than 1. So if a is 1/3, we're going to have to plot 1 comma 1/3. So here, our y value is going to be less than 1 in this case. So let me just randomly pick the value of a. What can I do here? Maybe let's pick that's a. Then this point right here is going to be 1 comma a. Sorry, I forgot to label this point. This point will be -1 comma 1 over a. So in general, our graph is going to look something like this. And this tail end is never going to touch that x-axis. And the left tail end is going to shoot up to positive infinity. Now let's make a summary. Properties of the graph of f of x equals a to the x, where a is less than 1. Let's first go with the domain. The domain is suitable x values where the graph is defined. So notice that this graph is defined all along the x-axis. So again, our domain is going to be all real numbers, which is from -infinity to infinity. Now let's go with the range. So range is the set of all y values where the function is defined. So again, when you try to find the range, you're going to have to look at the graph bottom upward. So again, our graph is going to start from 0, but it's never going to touch y equals to 0. So here, what we need to do is do the same thing as when we did in example 1. So you're going to start out with 0 with the open parentheses around it, and then it's going to go towards positive infinity. Now let's go with the x-intercept. Does the graph ever going to cross that x-axis or touches the x-axis? Nope. So there are no x-intercept. So I'm just going to write it as none. Next, the y-intercept. Where does the graph touches or crosses that y-axis? Well, again, at when y equals to 1. So our y-intercept is 0, 1. Now the key points are listed right above when x is -1, 0, and 1. So besides 0, 1, our key points are -1, 1 over a, and then 1, a. But please note that our a is less than 1, so this value right here is going to be bigger than 1. All right, and then this a is going to be less than 1. Now the asymptote, we have a horizontal asymptote at the line y equals to 0. It's the same thing as the x-axis. So I'm just going to write it as asymptote at y equals to 0, which is same thing as the x-axis. And the basic shape of this graph, do you see that it's decreasing? So I'm just going to write it as note, graph is decreasing. Now let's try something like this. Graph f of x equals to 3 to the x and g of x equals 3 to the x minus 2. Alright, so I believe that we did graph 3 to the x earlier, but why in the heck not? Let's try it again. Let's make some charts here. So I chose from -2 to 2. I want to make sure that I'm going to include the key points, which are x equals to -1, 0, and a 1. All right, let's do this. So when x is -2, we're going to have 3 to the -2, which is 1 over 3 to the second power, which is going to give us 1 over 9. So here we need to plot -2 comma 1 over 9. When x is -1, we're going to have 3 to the -1, which is 1/3. So you got -1 comma 1/3. When x is 0, you're going to have 3 to the 0. So again, we're going to have 1, 0 comma 1. And when x is 1, we're going to have just 3 to the first. So here we're going to have 1 comma 3. And when x is 2, we're going to have 3 squared, which is 9. So we need to plot 2 comma 9. All right, now let's deal with g of x. G of x equals 3 to the x minus 2. So if I do the same thing as what we did with f of x, here what we're going to get is 3 to the -2 minus 2, which is same thing as, remember we already computed 3 to the -2, that which was 1 over 9. So we're going to have 1 over 9 minus 2, which is going to give us -17 over 9. So here we're going to get, when x is -2, our y value is -17 over 9. All right, now when x is -1, we're going to have 3 to the -1, which is 1/3, and then minus 2. And what the heck is that? -5 over 3? So here, we need to plot -1 comma -5 over 3. And when x is 0, be careful here, you're going to have 3 to the 0 minus 2, which is 1 minus 2, which gives us -1. So here we need to plot 0 comma -1. And when x is 1, we're going to have 3 to the first minus 2. It's going to give us 1 back, so we need to plot 1 comma 1. And when x is 2, we're going to have 3 squared minus 2, which is 9 minus 2, 7. So we're going to get 2 comma 7. All right, now let's graph. So first I'm going to graph our f of x. So when x is -2, y value is 1 over 9. So it's going to be maybe right here, a little bit closer to the x-axis here. Now when x is -1, our y is 1/3. And when x is 0, 0 comma 1, and 1 comma 3, and then 2 comma 9. Well, I'm just gonna have to go above this graph, so I'm just gonna go like this, and just gonna keep going. So this is the graph of f of x equals to 3 to the x. Now let's compare that with our g of x. So when x is -2, we're gonna have -17 over 9, which is approximately, what is that, -1.9, very close to -2. So let me just jot down, here's -1, -2. All right, so it looks like I'm gonna have to plot maybe right here. All right, now let's go with when x is -1, our y value is -5/3. That's same thing as -1.7 approximately. So when x is -1, our y value is -1.7. -1.7 would be maybe over here. And when x is 0, y is -1. That one was easy. And next one is 1 comma 1. And then 2 comma 7. So 7 is going to be outside of this grid. So I'm just going to connect what we have here. Oh my goodness. I'm doing the best I can here. Here we go. All right, so this is our graph of g of x equals 3 to the x and then -2. All right, now let's talk about the natural base e. So what is it? We're going to see this e quite a bit in a math class from this point on. So the natural base e is defined as the value of quantity 1 plus 1 over n, whole thing raised to the nth power as n increases without bound, which means that our e, it's going to equal to 1 plus 1 over n to the n as n goes to infinity. All right, now in calculus, we're going to write this as, just in case you're interested, we write it as e equals to the limit as n goes to infinity of 1 plus 1 over n to the n. And then this is the formal definition for e. Also, our e to the first, which is just e, is actually a numerical value. E is approximately equal to 2.7182881. I think next one is 827 if I memorized it correctly. But anyways, so basically E is a number. E is going to be a decimal value, and that decimal never repeats and it never ends. Our next definition, which is the natural exponential function, involves E now. The definition of the natural exponential function is an exponential function whose base is e, which is denoted by f of x equals e to the x. The domain is all real numbers, and then range is 0 to infinity. Now, again, notice that e is approximately 2.7, correct? So, e, the value of e is greater than 1. So when you graph e to the x, it should have the same behavior as the exponential function whose base is greater than 1. Now recall those key points when the base is greater than 1. Those key points were when x is negative 1, y is 1 over a, and then 0, 1, and then 1, a, if a is greater than 1. So in this case, our a is e. So if I want to graph this out, at x equals to negative 1, I need to plug it in 1 over e for the corresponding y value. Now, if you punch this in the calculator, you're going to have to type it as 1 divided by e to the first power. And if you hit enter, that should give you the decimal value of 0.36787 and so forth. So this is approximately 0.4. So let me see. 0.4 might be right here. So this is the point, negative 1, 1 over e. And then when x is 0, y is 1. Now, when x is 1, it's going to be e. E to the first, which is approximately 2.7. So 2.7 should be maybe right here. So again, we should expect that the graph is going to be an increasing graph. So this will be the graph of y equals e to the x. So let me just write this key point. So this is 1, e, which is approximately 1, 2.7. Okay, we're done with graphing for now. Now our next topic is solving exponential equations. To solve the exponential equations, we're going to have to know this property. So it says that for a greater than 0 and a does not equal to 1, if a to the x equals to a to the y, then x must equal to y. So basically, let me just give you a little example. So do you see that if, let me see, 3 to the x equals to 3 to the maybe 2 or something like that, then do you see that this means that x must equal to 2 because the bases are the same. So that's exactly what this property is telling you to do. Now here are some simple steps to how to solve an exponential equation. Step number 1, write both sides of the equation with the same base. Now sometimes you cannot equate the bases. So in that case, we're going to try something else. Step number 2, Write a new equation by setting the exponents equal. Step 3, solve the equation. And step 4, check the solution. I think the best way to learn this is by doing a bunch of examples, so let's get started. Example 4, solve e to the x squared over e to the x equals e squared. Alright, do not panic. I know that you have so many e's flying around, but treat e as a number. Pretend e is a numerical value. But first, let's talk about this one. So if you have a to the m over a to the n, how do I divide those two? Is by taking the common base and then you subtract the top exponent minus the bottom exponent. So that's our first step to simplify the left-hand side of the equation. So here what we're going to get is e to the x squared minus x equals e squared. All right. Now, do we have the same base? Yes, I think so. We got both base to be e. So next step, equate that exponents. So this implies that our x squared minus x must equal to 2. Now remember what we're doing. We're trying to solve for x. So what would you do? Well, I will bring the 2 on the left-hand side and then set the right-hand side equal to 0. So here I'm going to rewrite this as x squared minus x minus 2 equals to 0. Now, does this factor? Let me see. You got an x plus minus, so it looks like we're going to have 2 and a 1. Does it work? So if I FOIL it, I get x squared and then negative 2x plus 1x. That should be negative x and then negative 2. The last term, when I multiply that last term, it should be negative 2. So this is good to go. So that implies that either x plus 1 is 0 or the x minus 2 is 0, which means that x is negative 1 or x is 2. So let me just box our proposed solution and we check. All right, let's check our proposed solution when x is negative 1. I'm going to plug that back into the original equation. So here you're going to have e to the negative 1 squared over e to the negative 1. Is that going to equal to e squared? So this is what we need to compute. So let's work it. So from this side, if I combine this, you're going to have e to the negative 1 whole quantity squared is 1 over e to the negative 1. Now how do I simplify that? Is e to the top exponent minus the bottom exponent. So be careful right here. If I subtract the bottom exponent, you're going to have minus and then negative 1. So this is e to the second power, so it checks, it matches up. All right, so therefore x equals negative 1 is a keeper. All right, now let's check when x is 2. We're going to do the same thing. So we're going to go e to the 2 squared over e squared. Is that going to give us e squared? All right, so we're going to do the same thing. So this portion here becomes e to the 4th over e squared, which will give us e to the 4 minus 2, which is e squared. So it works. So therefore, we get to keep both of them. Our solution set is negative 1 and 2. So I'm going to box that for the answer. Check out that curly bracket on the right-hand side. Oh my. But anyways, hopefully you're able to follow that example. So let's do another one. Let's try solve 4 to the x plus 3 equals to 16. So step number 1, we need to rewrite this so that we have the same base on the left-hand side and the right-hand side. Well, can I not do this? How can I write 16 in terms of base 4? Isn't it 4 squared? So here, what I'm going to do is rewrite this as 4 to the x plus 3 equals to 4 squared. Well, now that we have the same base, we're gonna equate the exponents. So we get x plus 3 equals to 2. Oh, this one was way easier, huh? So that implies that x equals to negative 1. All right, so now we check. When x equals to negative 1 is 4 to the negative 1 plus 3. Question is that going to equal to 16? So let's compute this side. On the left-hand side to get 4 to the negative 1 plus 3 is squared, which will give us 16, which matches up. So therefore, our solution set is negative 1. Let's try another one. Let's solve e to the 2x times e to the third equals e to the 9. All right, so step number 1, we got too many e's going on, so we need to combine the left-hand side into one single base of e. So let's recall this property. If I have a to the m times a to the n, what would you do with those exponents? Yes, you add them. All right, so first step, I'm going to simplify the left-hand side of the equation by using this property. So here you're going to have e to the 2x plus 3 equals e to the 9. All right, now we have the same base on the left-hand side and the right-hand side. I'm going to equate the exponents. So now we have 2x plus 3 equals to 9. So that implies that we have 2x equals to 6. Dividing by 2 to get x equals to 3. All right, now let's check. When x equals to 3, that's e to the 2 times 3 times e to the third. Is that going to equal to e to the 9th? All right, so let's work on the left-hand side. So what do we got? We got e to the 2 times 3, which is 6, times e to the third. So what do you do with that 6 and a 3? You add them, which will give us e to the 9. So it matches up. So therefore, the solution set is just 3. Our third topic in this section is to use exponential models in applications. Now, one of the famous one is the problem involving compound interest. There are two formulas for the compound interest equation. One of them is if it's compounded n times a year, and another equation is for compounded continuously. But let's just read it together. All right, so compound interest for principal P invested at an interest of rate R for T years. The new balance A is denoted by A equals P times the quantity 1 plus r over n to the nt power. Nt means n times t. Now that formula is for the interest is compounded n times a year. And another formula is A equals P times e to the RT. Now in this case, the interest is compounded continuously. Now let's take a look at some examples involving compound interest. Example 7, let's try something like this. A total of $15,000 was invested in a college fund for Angela. If the interest rate is 5%, how much would it be in the account in 17 years by each method of compounding? So let's go with part A, compounded quarterly. I cannot say that word. And part B, compounded monthly. And part C, compounded continuously. Before we begin, let's just review a little bit. So for both equations above for the compound interest, A stands for the new balance, P is principal, which means how much money you started out with, R is the interest rate, T is in years, N is the number of times compounded in a year. Let's try A, compounded quarterly. Now quarterly, the word I cannot say is 4 times a year. So let me just write it, 4 times a year. Now let's write down what we're given and what we're looking for. So I'm going to go with A, P, R, T, and then N. All right, so let's go with what we know so far. The principal, are we given the principal starting amount? Yes, that is $15,000. All right, now what about the interest rate? That's 5%, so in decimal, you gotta go 0.05. Now, how many years are we talking about? In this problem, it's 17 years. So I'm just gonna write 17 years. And N is the number of times compounded in a year, so in this case, it's 4. So the question is, what is going to be our new balance? So we're trying to find the value of A. Since we're compounding 4 times a year, we're gonna have to use the top equation for the compound interest, which is we need to use A equals to P times 1 plus R over N to the NT power. All right, so now let's plug in all the values that we got. So what we want is A. So we got P is 15,000, and then we have 1 plus 0.05, that's a 5, sorry, over 4 to the N is 4, times T is 17. You definitely gonna need a calculator for this. So get your trusty calculator out and please compute this value. And I'm gonna do the same thing. All right, so what I got was the new balance to be $34,910 and approximately 29 cents. But I'm just gonna leave it as 34,910. Now, when you use your calculator, the order of operation matters, so be careful right there. And if you have any questions about how to input it in your calculator, please reach out to me. I'll be more than happy to show you how to do so. Anyways, I'm going to box this for the answer for part A. Now, let's take a look at part B, compounded monthly. So monthly means what? 12 times a year. All right, so keep that in mind and let's do the same thing. So what we're looking for is the value of A, and then only thing that's gonna change is the value of N. So here, let me just write everything out. So our P was it 15,000? And then R was 0.05, and then T was 17 years, and then our N now becomes 12. Now let's use the formula A equals P times 1 plus R over N to the NT power. Okay, so we got A equals 15,000 times 1 plus 0.05 over 12 in this case to the 12 times 17. All right, calculator time. So I'm gonna pause the video and try to calculate this on my trusty calculator. Please do the same. Okay, so I got the new balance A to be 35,032 and 78. All right, so that's what I got. Hopefully you got the same answer. So I'm gonna box that for part B. Now let's try part C, compounded continuously. So in this case, our formula changes to A equals to P e to the RT. All right, so let's do it. So our A is what we're looking for. So A equals, principal is 15,000, and then e to the R, which is 0.05, times T is just 17. All right, so please pause the video again and use your trusty calculator to compute this value. Okay, what did you guys get? I got A equals to, the new balance is going to be 35,094 and 70. Yes, so I think this is correct, so I'm gonna box that for the answer. So if someone is going to invest in a college fund for Angela, and if he or she compounds continuously, then Angela will get the most money. Regardless, I think she's a very lucky girl. But anyways, I'm going to stop here. So if you have any questions at all, please let me know. And great job, everyone, and I'll be talking to you soon.